look what I have. I have a Panasonic plasma th42pa20 2004 vintage, but look at this sucker, 425 watts. Like, this sucker draws a lot of power. This one was donated to me today, and it is totally dead. Well, I shouldn't say totally dead. The power light blinks, I think it's 11 times. So I didn't get the base for it. I have to prop this thing up to work on it, which I really don't like it when I don't have the base to prop the thing up with, because it makes it a little more difficult to work on. But let's get the back off this thing and see if we can get it going. So exactly 35 screws later, the back is ready to come off this beast. And there's going to be a lot of circuitry in this thing. Look at that. Wow. We've got, let's identify the boards on this set. So we've got, this will be our Y sustain or equivalent. I would think this is the buffer board, but it doesn't look like any buffer boards that I've seen. They call it the SD board on here, but it is still a buffer board. This is a standard definition panel. There's only 6 ribbon cables going out to the panel, so this is our buffer board. The chips are probably mounted on the other side of this board, and that's why we don't see them. Is the chips are probably on the underside of here, which they are. I can feel them. So our buffer chips are on here. Is our upper on our lower buffer board. This is our Y sustain board on the set. We have our digital board or input board. We got a whole bunch of boards on the set here. Obviously this is the power supply, and we've got 2 more signal boards here. I have no idea what these do because I haven't actually studied one of these sets yet. And here will be our SS board, or sometimes called the X main. This is our common driver for the panel on this board here. So first thing we got to do is we have to determine why this set's not starting, and it's likely, it could very well be something in the power supply, but again, I haven't actually done any voltage tests yet, so that's the first thing we'll do. Is I'm going to see whether we've got our voltages correct, see if this set we can make it start. So when working on any of these TVs like this, it's always a good idea to have your service manual handy. In this case, what's nice about modern televisions is that, well, we used to have these big paper manuals that you know, you had to fold out across the desk, and now we've got service manuals available in PDF format and can download them to the tablet. We have 12 blinks of the power light, which is indicating a PA board base voltage failure. So that's be the 12, or the 15, the 12, the 9, the 5, and the 2.5 volts on the PA board. So according to the service manual, if we look down at the service manual here, it's telling me that 12 flashes is a failure on the PA board. Where are we here? This is the PA board here. And on the television, the PA board is this one right there next to the power supply. This is their DC to DC converter board. That's also the audio output board. So 12 flashes is telling me to look at that board. So if I look up the actual, so DC to DC converter and the audio. So I realize we're looking at the set upside down, but PA7, which is this connector here, this is on the top. This is the top side of the set here. PA7 is the input. It's supposed to have 15 volts on it when we power the set up. So we're just going to probe pin 1 and 2, which is the 15 volt input, as we try turning the TV on, and see if our 15 volt input comes up to 15 volts. If I can find the power button on here somewhere. Okay. I don't see the 15 volt supply coming up. That's coming off of the 15 volt supply over here, which is pin 1 and 2. We're just going to unplug this connector here and just see whether we've got any voltage here. Okay, it's 6 volts. I'll try powering this set off and back on. See whether the 15 volt supply comes up. So now the 15 volt supply is there. And I don't hear the set shutting down. We go back and plug the board in. I think this is the test point there. It's only coming up to 11. So one of two things is happening. Either the power supply isn't putting out enough voltage, which would put us on, that would put us on this board here, the 15 volt supply, or something on here is loading it down. One of the two. Just in case I wasn't getting a good reading from the plug here, I'm just going to measure the voltage at the IC. So pin 1 here is the input to the regulators. We'll see if our voltage comes up now. Okay, so our 15 volts is present. And then it shuts down. So we know it's not the 15 volt supply. We'll look at some of the other supplies and see whether the problem is with some of the other supplies supplying this board. There, much better. Rather than trying to navigate through 3 pages of schematics on my tablet, I've broken down and printed them out. So at least now it'll be a little easier to figure out where things go. Nothing beats a good paper print. So we're going to check our voltages going into the PA5 connector, which is this one right here. This is another supply to this board. So I'm just going to put my ground probe in to the chassis, and we'll measure some of the voltages going in here. Now that I've got my schematic all put together like this, makes it just a little bit easier to see exactly what's going on the set. As I say, trying to work off of a screen when you're looking at 3 separate schematics, it's fairly difficult when you've got to start opening up PDF files. So a lot of times it's easier just to print them, stick them together, and now I can follow the schematic through, follow the print, and we're going to take a look and see if we've got any missing or low voltages coming in from the power supply board. So let's do some tests. So my 12 volt supply is a little bit low. It's coming up at about 11.7 volts. That comes back on this is the power supply board to this one here. I think it's C576. It's 2200 microfarad, 25 volt. So we're going to go back to the power supply board and we're going to look up that capacitor and see whether maybe it's gone a little high in ESR. So that one right there on the power supply board, that's C576. That's the main filter for the 12 volt supply. So we're going to pull the power supply board out and just take a look at that one and see whether that may be where our fault is on this set. The 12 volt supply is a little low. If the 12 volt supply is a little low, the set starts to power up and you can actually see the panel start to initialize. You see the glow come on from the panel and then it shuts down. So it could be reading the low voltage and just going into protection mode. That's what my feeling is now, is that the voltage is a little bit off. So we're going to pull this power supply out and check these caps out. And of course, when working on power supplies, what do you want to do when you take them out? You want to make sure that all the filter capacitors are discharged, all the big ones. So just short across your big filter capacitors. I've already done this, but just make sure you discharge your capacitors, because these things can store a nasty charge for a period of time after the power is removed. So I've got the board lifted out. We're going to get the ESR meter out and just check some of the ESR on some of these caps here and change out any ones that we find may be defective. So as I continue to troubleshoot, I'm moving from one board to the next. I've got it isolated down to the digital board, has some type of an overload on it. If I unplug this connector here, which is feeding from the power supply to the digital board, it's PA2. I can plug the set in and power the set up, and it will stay powered up. you'll see our lights will come on our sustain boards, our SS board. Our health lights are on, the red little LEDs are lit up. And I can hear the deflection going on the boards, and the set will stay on. As soon as I reconnect the digital board to the power supply, you hear the relay click and the set goes into shutdown. So we're going to have to go over and look at this digital board and see whether there's something on here that's drawing the power supply down, pulling the power down and putting it into a fault mode. So we dig a little bit deeper on this one. A little bit more involved than when I first started working on it. Everything looked pretty straightforward, like we were going to have a power supply problem. But it's now starting to look more and more like we may have a component failure on one of the digital boards, or the tuner board, or something in the input panel. So what I've determined on this set is that my 9.2 volt supply is not coming up, which is this regulator right here. And it feeds in through the Zener diode. And it's only coming up at about 2 volts. So what I need to determine is, why is the 9 volt supply not coming up? Is something drawing too much power, or is the regulator itself not switching on? So what we're going to use is, we're going to use a 9 volt battery right here. When I power up the set, I'm going to connect the 9 volt battery up. Actually, I'll connect it to the battery, then I can just ground it to the chassis here. And that will supply me with the 9 volts that I'm missing. And we'll see whether that allows the set to stay on. If the set stays on, substituting the 9 volt supply, then we'll know that we've got a problem in the regulator here, and I can troubleshoot that particular circuit. If it goes off, then it's because something is drawing too much current. That 9 volt supply powers up this DC to DC converter. It also goes over to the digital board, and I'm hoping it's not something in there. But let's see if we can power the set up, forcing it up with an external supply. So I put power to the set, and now I'm just going to turn on the set and bring up my 9 volt supply. So now we've turned on the set. Whoops. Yeah, it's gone off. And I see some smoke. Did we burn something? I don't know if you saw the little bit of smoke that came up there, but something on the digital board here is where the problem is. We have a short somewhere on this board here. It's drawing the 9 volt supply down, so I got to investigate that board. But without the digital board plugged in, I can turn on the TV and I get my 9.2 volt supply, 9.3. So it's working. The 9.3 supply, and of course the TV will stay on. If you notice, the little red lights here are on the sustain board. The TV is actually running now. I can hear the sustain board is running. So the scan drive is actually on the panel and it's working. The 9.2 supply also supplies this switching PWM switching regulator, which should have 30 volts to pin 1 for the digital board. So we'll just check pin 1 over here and see if we have our 30 volts present. Pin 1 is right over here. We got 9 volts on it. Volts there. 9 volts on that regulator. It actually could be the boost regulator, the PWM regulator, which is right in this area here. This produces 30 volts, but it's not. It's only coming up 9 volts. It's like the PWM regulator is not running. I'm going to put a scope on it and see whether we can see why it's not working. But it may not work unless the digital board's connected, because there's no load on it, right? So that might be why the voltage isn't where I expect it to be. I'll show you the scope here. This is the output from the PWM, which is the 30 volt generator. So basically it's IC7581 right here, and operates through this transistor. I'm going to measure it right here on the collector, which also goes through this coil here. This is your boost converter. So I'm just going to measure that collector, and we should see a PWM signal show up here when I power the setup. Let me just get my scope probe in the right place here. So I'm on the collector now. I'm going to turn on the set. And if the IC is working, we should see, okay, there, we just saw something kick. There we go. You see, we've got, I don't know if I can lock the scope on, but we have a PWM signal here. Pulse width modulation. You see it? I don't know if I can trigger my scope on it or not. It being an analog scope, but you can certainly see it. You can certainly see it there. So that means that the 30 volt boost circuit is working. Our 9 volt supply is being drawn down by something on the digital board, so I'm going to have to go and print up the digital board schematic. That's going to be fun. And see if we can find where the 9 volt source goes and why we're losing the 9 volt source on the digital board. What is drawing the 9 volt source down and shutting the set down? Something on the digital board. So I'm going to go get the schematic for that and print it, and we'll be back to work on this thing. This has become a real challenge. The video doesn't show it, but I've already spent about 6 or 7 hours troubleshooting this dog. These old plasma sets were a complicated, very complicated television. The new ones are relatively simple, but just all the discrete components, these things are probably the most complex televisions I've ever worked on. It's totally not worth fixing, other than the fact that this has become a challenge now to see if I can get it going. Well, I'm on the right track. It's my 30 volt boost line. Comes up from pin number 1 from my boost. Pin 1 takes 30 volts over. It's the tuning voltage for the analog tuners. I found it dead short. The tuner board is unplugged from this set now. I've got the tuners completely removed. I still have a dead short on pin 1. Looking at the schematic on the digital line, pin 1 goes through a little delay line. I don't know why they got that in there. And then it goes over to the connector here. So I cut pin 1. Cut the wire for pin 1. As you can see, my lights are on here on the set. The set is running. My 9 volt supply is back. I don't know if you can see that or not. There's the meter. Okay. My 9 volt supply is back. And my set's not shutting down. I don't have any video because obviously I've unplugged the tuner board. I'll plug that input board back in and see whether I can get an analog source from something other than the analog tuners. But I got the set to stay on now, so it's not going into shutdown mode now. So I'm definitely narrowing the problem down. We have a short on the 30 volt boost line. And again, that's just for the analog tuners. So if the set works without the analog tuners, I'm happy because there's no more analog broadcasts anyway. So really the analog tuners are a moot point. Let's see, I'll hook up the input panel, hook up the analog inputs and see whether we can get anything from the analog inputs for the set. The moment of truth. Mr. Remote Control. Holy smoke! I believe this set's working. This thing doesn't have HDMI in it. Okay, I'll have to find something to plug into component 1 and we'll see if we get a picture. Actually, it doesn't look bad. It's not a high definition panel, But you know what? For free, I'm not complaining. It actually looks pretty bloody good. So now that we've got this set working, I'm curious as to whether I can actually find what's shorted on that board, and I have a pretty darn good idea what it is, because the 30 volt line goes directly from, it comes in from the power supply, the DC to DC converter, and then it goes onto the digital board, goes through a little filter, and then it goes directly over to the tuner. And I have a feeling that that little filter that it goes through is shorted, because there's nothing else on the board. It's a direct pass through from one board to another, so it's got to be that filter. Again, it might be wasting my time. I'm just kind of curious as to what went wrong with it now, because anything that a TV like this is going to be used for, it's going to be used for, you know, looking at a digital source, either through a digital converter box or from a DVD player or from a cable TV box. Because the tuners that were in this set were analog only, but it did have two tuners, so it could do picture in picture. But again, there's not a lot of analog content now these days, from cable anyway. The cable companies are getting rid of the analog signals, and there is no more broadcast analog off the air anyway, so I probably am wasting my time. I just would kind of like to see what was causing the fault. Again, I spent a lot of time, about 7 hours on this TV. If I was in the business of fixing a television, I would have lost my shirt on this thing. Maybe not 7 hours, but we'll say a good constructive 4 hours of work on it. I've been kind of tinkering around with it on and off, but as far as actual sit down time working on this thing, it's probably a good 4 hours, just tracing from one circuit to another. But it actually is not bad. The picture's not bad. It's not a high definition panel, but it's still it's not a bad picture at all. In case you guys wanted to see the part that was shorted, there it is. That's the part that's causing the problems on this set. And it's just a little filter. I'll show you where it went on the chassis. It's mounted right here. It's LC 4371, and all it does is the pin 1, which is the power supply input here from the boost. Pin 1 goes through that filter, comes back on this side, and here's where it continues on the circuit board and goes to the tuners, which I haven't mounted yet. So if I just connect a wire up to here to my boost voltage, I've taken out the part that's shorted. You guys probably couldn't see where I was scratching, but right here, this is the output side of that filter, that coil. This goes to the tuner. So if I apply my 30 volt supply, I'm just going to bridge a wire in there, and I can put my tuners back in, and I'll see whether the analog tuners actually will work. Okay, I've remounted the tuners. They just plug in to the tuner board, and now I've hooked up a cable to it. Let's just see whether the inputs will actually do anything. Well, that's a good sign. Yeah, there we go. I'm on antenna 2. That's why I had it switched to antenna. I had it switched to antenna 1, and I hooked up my cable to antenna 2. So I should see my security cameras, which I do. I should see my house cable here, but I'm on I believe this is set for cable. So if I try dialing in, yeah, it's on CATV. There we go. Now it's working. I can dial up my in-house channels. So to recap, haha, bad pun. Our problem was the little filter down here that filters the 30 volt supply for the analog tuner. How the set operates is the 9 volt supply is regulated from 12 volts here on the linear regulators, which are these regulators here. So I was able to test and find that my 9.2 volt supply was missing. 9.2 volt supply is fed down to the digital board through this connector. It also goes through the boost circuit here. This is just a pulse width modulator. Basically generates a series of pulses, so changes the pulse width to vary the voltage. It's a little regulator, DC to DC converter. Very simple, no transformer or anything, just uses an inductor and a diode and some capacitors, or a capacitor. And transistor, I say oscillator, transistor, a diode, little coil, little inductor coil, which is, where is it? It's right, where was that thing? The inductor's right there, that little capacitor was over it. So just a little inductor coil to generate the 30 volt boost, which is passed on the white wire here over to this connector. From here it goes straight over to the tuner, and it was shorted, so I just replaced that little inductor that I showed you with a piece of wire that got the analog tuners working. The analog tuner is kind of a moot point. It's kind of useless, but I wanted to keep it working because I'm going to be getting rid of this TV. I'm not going to be keeping it, so I wanted whoever gets it to have a set that is at least properly functional in case they hook it up to a VCR or something and hook it up through the coaxial input, or they're hooking it up through an analog cable system on channel 3 or whatever. So I wanted to make sure that at least I could get the analog tuners working. So now the process of just reassembling the set. I got dozens of screws to put in on this thing. I think there was like 35 screws, something ridiculous like that, but there's a bunch of them, so I'll be putting this thing together for a while. Hope you enjoyed this video, and we'll catch you in the next one. And there it is, all back together, ready to go.